Away. So now we are working on quadratic equations. Let's get started. Cool. So for quadratic equations, there is just an idea that I'm going to show you guys. I also have to keep in mind, probably this is the first time you guys do quadratic equations, like solving for x with quadratic equations. I forgot actually, what did you guys do in grade 9? Or maybe I didn't check. Yeah, but the thing is, with quadratic, you want to get it to this point where you have these two brackets. You have two brackets multiplying together being equals to 0. You see, when you are at that point, you are done solving for x, because now with this bracket we are saying if at least one of the brackets is equals to 0, your answer is gonna be right, né? So you'd realize if I solve this one, I'm just gonna be like x plus 1 equals to 0, or 3x minus 1 equals to 0. Then here I have x equals to minus 1. Then here I have 3x equals to 1, x equals to 1 over 3. Look at what I am saying. I'm saying x can either be minus 1, or it can either be 1 over 3. Any of those values actually works, because in one of, like, for example, x being minus 1, it makes this bracket to be 0. 0 multiplied by anything equals to 0. You see it? X being 1 over 3 makes the second bracket, this one, to be 0. 0 times anything, it becomes 0. Do you understand it? Cool. So let's come here and try to apply the same idea, né? You have x minus 2, it's gonna be equals to 0, or x plus 5 equals to 0. Then you have x equals to 2, or x equals to minus 5. Do you understand? So now 2 makes this bracket to be 0, making the whole thing 0. Minus 5 makes this bracket to be 0, making the whole thing 0. So we are still, do you understand? So that's how we actually do it, né? Yeah. So the thing is, though, like with most problems, you get them in this form, you'll have to do your own factorization. You realize with the two problems we have already done, they have already been factorized for us. So a lot of job has been done for us. Ours is just to now do the solving, né? Yeah, but let's look at this. Let's look at this. How are we going to factorize this? There are actually two methods. Just so that they become like, I pray that you find the method that really works for you, né? For me, I love the shortest ones, né? If a method actually gets me to the answer, while at the same time avoiding many steps, that's my method. But let's start with that one. So when your coefficient is 1, the coefficient of what? Here it must be x. When the coefficient of x squared, if you're factorizing a quadratic, meaning the highest exponent there is 2, yeah? The highest exponent is 2, so we go there with the variable having the highest exponent. We look at its coefficient. We're like, what is the coefficient? And as long as the coefficient is 1, here's what you do. Simply open your two brackets. After opening your two brackets, you have x, you have x. Nah? You look at these two. One of them is, both of them are negative, the signs here. Nah? So I believe it's gonna be plus and minus. Nah? So now the question we answer, we look for this question, we're like, okay. Also another thing is a conversation. Okay, I'll explain why I chose plus or minus to be the signs. It's very clear. So you look at these two numbers. Are there any two numbers that If I multiply them, I'm gonna get 18. Forget about the sign, but these two numbers, when I multiply them, I get 18. At the same time, these two numbers, I can either add or subtract them, and I will get the middle number, which is 7. Forget about the sign as of now. And the thing is, yes, they are. It's 9, right? 9 multiplied by 2, 18. 9 minus 2, 7, right? Cool. And then now you look, let's look. What is the sign for 7? It's negative, ne? So meaning that both these numbers, they cannot be positive. One of them is gonna have to be negative. But then what actually tells us if whether both numbers are gonna be positive or both numbers are gonna be negative? It's the sign here, ne? Because that sign, how do we get it? We get by multiplying the two numbers. So if I multiply 9 and 2 and I get minus 18, it implies that one of the two numbers is negative. So for me to find out which number is negative, look, if 2 is negative, I get a positive 7. But now if I have 9 being negative, I get minus 7. So that means here I'm going to have minus 9. Here I'm going to have 2. Right? And you can try to expand the whole number. You will see that it gets you to the answer you want. Ne? It gets you to the answer you want. So when you are here, then we've already been talking about it. X plus 2 equals to 0, or x minus 9 equals to 0. Then you have x equals to 9. You have x equals to minus 2. You are done solving this problem, right? But I just want to say, you see, it takes time, or like it takes a lot of practice for you to be able to get those numbers, you see. So a lot of time I would say, if you're still having a hard time trying to get these numbers, try it the old way. The method, that old method that I showed you, it works everywhere, whether your coefficient is 1 or not. And if that method doesn't work, you know that if your trinomial can be factorized, you will not get rational numbers there. Yes, it will be able to be factorized, but you will definitely get irrational numbers. That's the thing. So if the method that I have already told you guys now, it doesn't work, then you know that probably we can still factorize this too, but then the numbers we're going to get are irrational. And I would say there's a case also where like the trinomial cannot actually be factorized. When you try to factorize it, you get non-real numbers. So, but these are things we'll get to later on. Here you could be like, I have 1 here, so 1 multiplied by 1 times 18 is 18. You look for factors of 18 is 1, and 18 is 2, and 9, 3, and 6. I'll end there. Then you like, are there any factors that give me the middle number, whether I add or subtract? The answer is yes, there are, and it's this 2. So therefore you come, you say you have x squared. Then you're like, okay, minus 9x plus 2x minus 18 equals to 0. Now you're going to what? You group them, ne? Now you group them, take out common factor, which is x this side, x minus 9, common factor that side is 2x minus 9, and then highest common factor is x minus 9. Right, then you end up with x plus 2 equals to 0. Then x minus 9 equals to 0, or x plus 2 equals to 0, leaving you with the same answer of minus 2 and 9, right? So if you really cannot use that method and be like, here's the answer, let me, this is the method that always works, right? And yeah, we have a very interesting example here. Let me tell you what it, okay, There's a mistake someone could possibly do. They see the number and they already try to expand the bracket. I don't know what actually is going to happen when you expand it. I don't want to do it, and I'm not going to do it, and I would like to advise you also not to do it. What I would rather say is look at the number, look at it very carefully. You would realize something we did do when we were talking about factorization, right? There's this thing when you are subtracting two squared numbers, we call it difference of two squares. So we have a squared number, right? Just to, you could, if you cannot, like, because also I know like there are people who, like, soon as this becomes so big now, like it becomes very hard for them to be able to, you know, work out this problem. So you could, if you are one of those people, you can be like, let because here we are using a, you could say let x be 2a minus 3, and therefore you have x squared minus 16 16 equals to 0. Then you have x minus 4, you have x plus 4 equals to 0, and then you have x minus 4 equals to 0, or x plus 4 equals to 0. Then when you are done, you then say therefore you substitute your x, 2a minus 3 minus 4 equals to 0, 2a minus 3 plus 4 equals to 0. Then now this 2, it's minus 7, and then positive 7, 2a, this 2, that is 1, so you have minus 1, 2a, and then a is 7 over 2, a here is minus 1 over 2. You are done. So I'm saying this, if you know like you can't work, soon as this thing is so big you can't work with it, just do this substitution thing and it always works, man. But then now if you are actually able to do if you can work with big numbers like this, right, then you are fine. You can be like, okay, I'm gonna have 2a minus 3 minus 4, close bracket, open bracket, 2a minus 3, right, plus 4 equals to 0. Then now you say 2a minus 3 minus 4 equals to 0, or 2a minus 3 plus 4 equals to 0. Then of course you have 2a plus 1, you have 2a minus 7, you have 7, 2a, just like we did, right, 7 over 2, just like we did, 2a equals to minus 1, a equals to minus 1 over 2, just like we did. This was beautiful. This was beautiful. Let's see what we've got next. Here, something really beautiful. We have fractions now, but for these ones you just cancel them very quickly. Now you just multiply everything here by 2y. You know for sure that 2y is going to cancel out with this 2y. And let's see what we have afterwards. So you're gonna have this side, you're gonna have just 54. That other side you're gonna have 3y, right? And then perhaps y squared, I'm sorry. And then let me see. Yes, the answer is 9. I think the answer is 9. Yes. So you divide by 6 both sides, you have y squared equals to 9, right? You have 0 equals to minus 9. And then okay, there's something I'm going to illustrate here, né? Yeah, in fact, from here to here there's something I'm going to talk to you about. Here you see you have difference of two squares, so it's y minus 3, y plus 3, y equals to y minus 3 equals to 0, or y plus 3 equals to 0, y equals to minus 3, y equals to 3, and then you are done. So what I want to illustrate here is some people, when it's not wrong, but here's what's wrong. When I get here and say y squared equals to 9, I used to do this square root y equals to 3. And I was 50% right, because yes, 3 is a possible value for y. We did show it, but there's another missing value also for y, right? So then they would say, when you put these square roots, when you put square root this, I say here plus or minus square root of, then you have plus or minus 3. But I mean, you could do it that way. It's kind of okay. There's no problem with it. It becomes more clear to me when I do it this way. Yeah, well, yeah, it becomes more clearer that way. Let's attack this one. Here you can start multiplying. You have 3y plus 1 plus 3. Say for example I have minus 2, 4 over y. Away.
I'm leaving, right?
Are you leaving?
Yeah.
Right. Always. My yeah. I'll be with my phones. Always. So I'm gonna multiply by y to get rid of this y, right? And don't ask me why. Cool. So here we're gonna have 4, we're gonna have minus 2y, we're gonna have 3y. I should have actually added these. We're gonna have 3y squared 3y squared plus y minus 4 equals to 0. So yeah, this is my favorite spot. You see, like that method where from here you automatically do your brackets. I will tell you the truth, me, I cannot do that. Yeah, I can't. I don't know, maybe if I had have practiced more examples and I tried to, probably I would have found a trick actually to do it, but I can't. So the method that always worked, that's why I love it so much. And if things get tough for me, I know that method, it will never betray me. It will never betray me. I go and look at my coefficient of y squared. I multiply that coefficient with the constant. The constant, which is what? 4. So yeah, let's do it. Coefficient, last term, 3 times 4, the number is 12. We look at the factors, it's 12 and 1, 2 and 6, 3 and 4, and that's it. Now, is there any pair? Like, I write them in pairs for a specific reason, because we can only use the pair. Now, we cannot use one number from another pair and another number from a different pair. We don't do that, right? So which pair, whether you add or subtract, gives you the middle number? The middle number is what? 1. We just focus on the coefficients, we focus on the coefficients, not the variables themselves. So the number is 1. So now we realize that the pair that gives us 1, whether we subtract or minus, whether we subtract or add, it's this pair. So we take that pair. Now you see you have 3 and 4, so probably it will be best also to put it this way. 3y, let me say 3y squared, then the 3 has to be negative and the 4 has to be positive, so that you get, you have 4 minus 3 is 1. So you have minus 3y and then plus 4y minus 4, 0. So now, since here it's just positive, right, we easily group them. Then you have 3y as a common factor, you have y minus 1, and then you have plus 4y minus 1, then common factor, you have y minus 1, you have 3y plus 4 equals to 0. Then here you are very done now, very done. Y equals to here 1, or maybe y equals to y minus 1 equals to 0, y equals to 1, or 3y plus 4 equals to 0, 3y equals to minus 4, and then you end up with y equals to minus 4 over 3. You see? Yeah, so for quadratic equations, man, when you are solving for x, a lot of times you'll be factorizing a lot. Yeah, well, so yeah, let's see what we can do here. I want to get rid of these denominators. So I'll just multiply by 3z and 3z. Fortunately, I have 3 here, so this 3 is gonna deal with this denominator here. When I multiply, I'm gonna have 10z squared, right? This 3 divides this one, then the z squares this one, and then here 3z, and then here the 3z is actually going to cancel out, so I'm gonna have just minus 1. Nah. But I'm realizing something. I thought let me make it interesting with different letters, but this one is gonna mess it up. It looks like 32 here. It looks like 32. So let's stick to the basics or the normal variable we use. So we have 10x squared minus 3x plus 1 equals to 0. Very simple. We go to the method. 1 times 10. You have 1 equals to 10. Factors of 10, 1 and 10, 2 and 5. And fortunately, these are the last ones. And this one, it gives you the middle term. So we're like, okay, 10x minus 5x, because 5 has to be minus, and then plus 2x plus 1. Nah, you're done. So you take out highest common factor, which is 5x. Then you have x, no, 2x minus 1. Wait. I'm seeing something actually very, very interesting here. Yeah, there is something very, very interesting here with this example. Because the thing is, now I'm not getting, okay, I'm not gonna get a common factor here, so I don't know, possibly if I did, because okay, let me continue just to show you. Let me use a different color just to show you. We could say common factor here is 1, then I have 2x plus 1, right? And the plus 1 is legitimate because this when it came that other side, you see. So what I want to do is I want to add a plus and ultimately add a plus here, and therefore this becomes a minus, right? This becomes a minus, and then it then becomes easier, right? We're gonna end up with 1 into 2x minus 1. Right, so here we're gonna end up with exactly, we have common factors now. We can say 2x minus 1, we can say 5x plus 1, right? 0, then 2x, 2x equals to 1, 5x equals to minus 1, x equals to 1. Yeah. No, man. Yeah. Let me see. So I'm getting 5 over 2. So I'm now going to test 10 into 0.5. And I'm getting, so the answer is the work. So everything should be fine. Let's do this one. Apparently this one is the last one. We can just multiply by y all over. So let's multiply by y all over. So but when you do that, you get y squared minus 3y minus, in fact I'd love to multiply by 4 also, so I'm multiplying by 4y. That means then I'll have 4, and I'll have 12, and I'll have 5y, and I'll have 4. Cool. 4y squared minus 12y minus 5y plus 4 4y squared minus 17y plus 4 equals to 0. Now 4, now I'm gonna have 4 times 4 equals to 16. You guys know where they're coming from. And then factors of 16 is 1 and 16, 2 and 8, 3, 4, 4 and 4. And a pair that gives me the middle number is this pair. So that means I will have 4y squared minus 16y minus y plus 4 equals to 0. Then I have a group of 4y squared minus 16y plus minus y plus 4, and then taking out the common factor in both, so I have 4y here. I am left with y minus 4. I have minus 1 here. I'm left with y minus 4. 0, y minus 4, 4y minus 1, 0. Therefore y equals to 4, or 4y equals to 1, and then y equals to 1 over 4. We are done. Thank you very much for watching this. I hope it was very helpful. I'll see you in the next video.